Welcome to the Quick Train Modeler video training series. This module will focus on importing LAS data to point cloud format. If you're new to Quick Train Modeler or unfamiliar with working with LiDAR point clouds, please first watch the basic point cloud manipulation video. LAS data can be accessed directly in Qt Modeler by clicking on the Open Models button. Simply choose the LAS file and click Open. This will load the point cloud, and if it's present, also the intensity information. For greater control over the LAS import process, click on the Import Model Data button. This will launch the Import Model Data window. The import format should be set to LAS, and the model format should be set to QTA. QTA is a relatively new format in Qt Modeler that gives you access to the full range of LiDAR attributes. If you're working with large models and your computer lacks the memory resources, you should be aware of two options. The first is Allow Compressed Data. Compressed data only works with the QTC format. In the case of models with no intensity, it halves the model size. The compressed option retains all points, but results in a slight loss of precision. Proxy mode allows for larger models and will fit in memory. It displays only a subset of the points, but it is important to note that any analyses are actually done on all points, not just the subset. If one clicks on Access Data in Proxy mode, and we click Import, we select the tile, you'll notice that under the decimation and crop options, the decimation level is automatically set to 10. This means that only 1 out of every 10 points will actually be loaded into Qt Modeler. I'm choosing to import a model in this case without the Allow Compressed Data option checked, and I'm not going to use Proxy mode. I'm selecting my LAS file, which launches the LAS import dialog. If you are loading more than one LAS file, pay attention to the processing options. Choose Process as Group if you'd like to treat your LAS files as a seamless virtual mosaic, or Process individually if you would like each LAS file to be treated as a separate model. Because I am only loading one LAS file, Process individually works fine. The LAS format options give me options to import intensity, RGB values if present, or choose to subset based on classification. This particular LAS file does not have RGB values, and we're going to get to the classification options later. However, I am going to choose to import the intensity values. If I click on the Import Intensity option, it's generally best to choose Auto Scale, although you can uncheck that and choose the min and max values if necessary. Scrolling down to the LAS header section, Qt Modeler will automatically read the LAS header file. This LAS file has a coordinate system. It's UTM Zone 18. Unfortunately, that hasn't been specified in the header file. Hence Qt Modeler listing the LAS projection as unsupported projection. However, down on the Georegistration section, I can specify it as UTM Zone 18 and click Go to import the LAS data. Because I imported this model in the QTA format, I have access to all the attributes from the LiDAR point cloud. I can access these attributes by holding down the Shift key and individually selecting a point. This activates the point query function. On the left, you'll see that it displays the X, Y, and Z and RGB values if they're present, and over on the right hand side it displays the full range of extended attribute data. The QTA attributes can be displayed graphically under the QTA button. I can choose to color by classification. In this case there are 3 classes, classes 1, 2, and 12, corresponding to above ground, ground, and overlap points respectively. The first, last, and intermediate returns. You'll notice in this case that it's actually quite useful for separating out tall vegetation such as tree canopy from other features. Also the number of returns. The number of returns also shows a distinction between tree canopy and other features, and also the return number. There are additional QTA attributes, and of course you can clear the colors at any time by selecting the Clear Colors option. We'll import the same model again, only this time we'll take advantage of some of Qt Modeler's classification filtering options. I'm clicking on the Import Model Data button, still using QTA format, and selecting the exact same LAS tile. Under the LAS format options, I'm going to check the box next to classification and click on the classification button. This launches the LAS filter selections. I'm going to select Class 2. Only those points that correspond to Class 2, that is the ground point classification, will be imported into Qt Modeler. As before, I'm going to select UTM as the coordinate system and click Go to import the LAS file. As you can see, we've re-imported the LAS point cloud. In this case, though, we've only included those points corresponding to the LAS ground classification, Class 2. Things like buildings, trees, and overpasses have been excluded. As mentioned previously, we can use the import model data function to load multiple LAS tiles, typically adjacent LAS tiles, into a seamless mosaic. Using the Shift or Control keys, select the adjacent tiles and choose to open both of them. Within the LAS import dialog, choose to process as group instead of individually. And just as we did with the previous imports, I'm going to specify the coordinate system because it has not been written to the header file. We now have two adjacent LAS tiles loaded as a seamless mosaic. We hope you enjoyed this video. Please visit the Applied Imagery website for additional Qt Modeler training videos.